Hello everyone, this is Terry with Features.io, and as always, I would like to thank you for joining us today. It is my pleasure to welcome back Jeremy Tang from SharkIndicators for today's webinar, Lessons from a Veteran Ninja Trader Developer. Throughout the webinar, if you have questions, please feel free to type them into the question box. I'll do our best to answer them throughout the event. This webinar will be recorded and posted on the Features.io website within 24 to 48 hours. If you're watching this afterwards on YouTube, please do us a favor and give us a thumbs up. If you enjoy it, please share, comment, subscribe to our channel. It really helps us a lot. Due to the COVID-19 outbreak, a lot of us are working from home now, so please bear with us with any sounds of dogs, small children in the background. For trading news, events, and information, follow us on Facebook, YouTube, and Twitter using @Features.io. And now, without further delay, I'll hand it over to Jeremy, and you'll get the pop-up to share your screen.
Okay, all right. Okay, just making sure everybody can see me okay.
Yep, looking good. Webcam looks good. She's all yours.
Yeah, put the webcam in there for just a minute there, so, or I mean just the last minute. As you can see, I'm working from home just like just about everybody else. My name is Jeremy Tang. I'm one of the founders of SharkIndicators, and just a little bit about me. I've been developing since really since I've been in elementary school, which is a long time ago, since I'm 43 now. So basically, coding has been a lifelong passion of mine, and I'm always kind of humbled because you know, you see things every day that remind you that there are still a lot of people out there that are better than you, and it seems like the more you know, and the more you get into the mastery of any particular mastery, I should say, you know, you learn that there's always more to it. So today what I'm going to do is actually show you a little bit about my coding philosophy, and hopefully I can sort of give you some good tips and tricks to use when you're developing as well. The thing about coding is there are many ways to skin the cat. There really isn't a right or wrong way to do anything. Software development in general is a very complex topic, something that, you know, people would take many years of schooling just to learn. A lot of you probably, you know, I'm guessing we've got a mix in here. There may be some of you that are actually self-taught, and some of you that maybe actually be schooled in software development. But I am going to make sort of the assumption that you already know basic syntax and C#, and a little bit of basic NinjaScript. And so instead, what I'm going to do is I'm going to show you kind of the more higher, what we call the higher level thinking, the structure, the philosophies, and even some problem solving techniques that I use when developing. And so kind of like the analogy I'm going to make is like, imagine you're a home cook, and you're learning from a professional, and there's some things that separate, you know, people that have been doing this for a long time, you know, as opposed to, say, a home cook, right? Typically a home cook will follow a recipe that they've seen online or something like that, whereas a professional would know how to create recipes, know how to do things like flavor profiling, or structure a meal in terms of the components that are needed, and also have really good kitchen habits. And so an analogy I'm going to bring to the table here is a really good chef, for example. I'm sure you've heard of maybe mise en place. That's the French term for basically having everything in place before you cook. That's an example of a really good habit. And just like that, just like in cooking, coding is very much the same way in terms of making sure structure is a big important thing I'm going to touch on today. And there's really good reasons why you want good structure in your code. And I'll be explaining as I go, but chunking things up, that kind of stuff, and then problem solving. So we need something to work with to begin with. So what I've come up here with my partner Zach is a simple system, and the system itself is not important here. The idea is actually to show you how I'd go about implementing it. Okay, so in this case, we have two main components, a stochastic cross and a configurable oscillator as a secondary component. And what I'm going to show you is how I structure things so I can combine the two components together and combine the logic. And so what we're going to do is sort of have a bias that we're going to compute, a long or short bias. And with the first component, the stochastic crossover, we're going to do a long bias when it crosses above this kind of like this low territory back into the middle zone here, so above say a 20 threshold. And conversely for the short bias. And we're going to do the same kind of thing with an oscillator, except we're going to make it configurable so that we can choose what kind of threshold levels we want to use. And we're also going to make the oscillator itself configurable, but I'm going to start kind of piece by piece. And that's another sort of main technique that I want to show you. So let's just crack right into it. Okay, so this is NinjaTrader I have up here right now. And the first thing I'm going to do is I'm just going to create a new, open up the NinjaScript editor. And just bear with me, I'm actually running inside of a VMware, which happens to run kind of at almost like a turtle's pace compared to the desktop computer. I just want a clean environment to actually do the coding in. So kind of while it's loading up that one window, it seems to take a little while, I'm going to talk about structure. Okay, so structure is very important. Just like say a cook having a clean kitchen is important. And the idea is you want to build your software so that, or your code so that when you look at it 6 months from now, you're not going through lines and lines trying to figure out the what you're going to change, or inevitably if there's a problem or maybe something you want to change about your code to enhance it in some way. This is something that we talk a lot about in our company, is the idea that when you're developing indicators or strategies, you're constantly iterating, constantly improving it. And you want to sort of not future-proof, but sort of develop your code in such a way that it is easy to change up and readable, and it's easy to sort of plug in new features and whatnot. So first thing I do is just create a new indicator, and I'm going to take full advantage of this great little widget that NinjaTrader has done, and I'm also just going to add the actual output lines in here. Okay, so we need kind of a long and a short output, and this is of course just to visually see what we actually compute in the end here. And I'm going to go with kind of what everybody seems to go with, which is green for long, and let's do red for short. Okay, sorry, a little bit slow on the mouse here. Okay, and I'm just going to go ahead and generate it right now. Okay, so the first thing that I like to do is actually, and this is something, a habit I formed a long time ago, back when, back when I was first learning how to code, and that's actually to sort of write out a description of what you want to do in English. And this is known as pseudocode for developers. And so I'm just going to go right to the onbar update, and I'm just going to add in kind of a couple crucial steps that I need to happen. So I want to compute the stochastic cross bias, so whether it's long, short, or no bias, and I want to compute the oscillator bias as well. Then with that bias, I'm going to see if both biases are agreeing. I'm going to output a long signal, and then similarly, if both biases are short, I'm going to output a short signal. Okay. Once we have that, all right, I can start to quickly fill in what I want to do. And one thing, this is, again, there's no right or wrong way to do this, but one thing I really like to do is actually, I like to reuse things that are already in the main application in NinjaTrader. So let me explain. The biases that I'm looking for are long, short, or flat, or rather no bias, right? When you say flat is no bias. And instead of sort of just declaring my own enumeration, when there's already one that exists already, I'd rather just use the one that exists. You know, that way, if you have other components and other pieces that you're building, and you know, you don't have to recreate it every time. You know, you just use what's out there. That's one of the very first things I do. You want to reuse as much as possible. Okay, so obviously this will not compile right now, but the idea is I'm trying to just put the skeleton in, because just like say a talented painter would do, right? You want to paint the broad strokes first. You want to paint the main form, and then you fill in the details afterwards. This is a very very simple way to go about breaking down your problem bit by bit. Okay, so now I've got, say, for example, if I had computed the stochastic, and I've computed the oscillator bias, I'm going to go ahead and actually write the actual main logic, which is just simply to see if they're both, in this case, if the oscillator is long and the stochastic is long as well, right? Right. I've been doing this kind of long enough that I just know, just by habit, if you're doing an equal sort of you're testing for equality, just to do a double equals. Common kind of newbie mistake is just to put a single equals, which in coding is actually an assignment, which is not what you want to do. Just over the years, it's almost like muscle memory. Sorry, that's an and. Okay, so we're just gonna. All right, they're both short. And what I like to do is, you know, just put placeholders in here, right? So you got a long signal, you're gonna do some work, right? You're gonna do something, you don't know what, or I mean, you kind of know what, but the nice thing about doing this is if you have the methods broken out so that it's, first of all, this is very readable, and this will be as long as the onbar update method will ever get. Okay, I'm not gonna, at least in this case, I'm not really gonna be adding more. But if you can imagine, right, for in the future, you're like, you know, I don't like the stochastic cross, I want sort of an SMA cross instead. You know, it's just a simple matter of just taking this line out and replacing it with an SMA, and then, you know, the rest of your logic might even just work out without, you can sort of rename these variables or something if you want. But this is a very clean way to do it, so that in the future, it's just very easy to just plug in like new methods and whatnot. Okay, so let's actually implement those long and short signals, right? And in this case, all we're going to do is we're going to be outputting to the we're going to be setting the bar values to certain color or certain numerical value, and this will take that first plot that was we'd called long, and that will actually set it to 1. You tend to make a lot of mistakes when you're typing it out, and believe me, guys, like, it is not anything to be embarrassed about. But this is actually another really big point I want to make, is mistakes when you're coding are guaranteed to happen, and this is just, I'm talking about just typos, and sometimes they're pretty hidden there. For example, okay, that short signal, you know, if you caught it quick enough, I actually had a 0 there at first, and then I switched it to a 1. Basically, there are 2 plots here, which means there's going to be two objects in this values array, and the first one, the index is 0, and that's going to be the long one. The short one's going to be index 1. You know, so don't worry about it if you run it and you're like, it doesn't look right, it doesn't look right. This is all part of developing, is actually, and it actually gets it to another point I really want to harp on, and that's you want to build a little bit, build the kind of almost bare minimum, and then test it. build, test, build, test. And this is kind of a pattern you kind of want to keep doing, because the more you test, the easier it's going to be to figure out where the problems are, right? So if you get to a point where you're like, okay, I've got 10 things to implement. You implement the first one, you test it, you make sure that little unit in itself works by itself, and then when you add unit 2 to it and it breaks, you can be pretty certain that the first unit is sound. You don't have to mess with that. The problem is most likely going to lie in that new code that you added. So it's a great way to sort of you want to keep your software kind of always running in some state that's workable and testable as soon as you possibly can. Okay, so just thinking ahead, I'm actually just going to make these plots just a little bit larger. Okay, so actually just going to turn the auto width on, because if it doesn't scale, it's going to be really small to see. And so I'm just going to take both of those plots and make them auto width. And let's go ahead and actually add. We now have to add the stochastic cross and the oscillator as well. Okay, so working backwards, and again, there's no right or wrong way to do this. Let's go straight to making the stochastic crosses first. Okay. Now, a couple things that are going to come to light immediately, and that is we are probably going to need some kind of threshold to measure around. Okay, and we're also going to have to reference the stochastic. Okay, so there's a couple ways we can do this. We can actually just go put the stochastic right in here, like this, like so. However, that's not something I like to do. What I like to do instead is I actually like to put define a kind of private or protected property that's just going to spit back the stochastics. And again, there's a good reason for this, right? One being that there's one place where this indicator is being referenced, or sorry, returned, or there's several places where it's being referenced, but there's only one place where it's sort of being, I would say, created. It's not quite accurate when I say that, but there's only one place where it's sort of being specified, I should say. And the nice thing about that is if you ever need to change these parameters, for example, you just do it in one place, and then anywhere else that you've got it, it's going to be updated. It's going to take effect. In this case, we're just going to be interested in looking at the stochastic D, and we're going to need some kind of lower threshold to compare against, and that's going to be a property as well. That's going to be actually user settable. We're just going to look at the last bar, basically crossing above that lower threshold. Again, we did say is going to create a long bias. All right, and just this is the way I like to code. If I've almost typed something out that's literally close to what I want, I'm just going to copy it. This, however, does lead to some mistakes because you copy it and you forget to change everything. But let's look at this carefully. We're gonna look at we've already determined the sort of long bias. The short bias is kind of the opposite. We're crossing below an upper threshold down. Okay, and we're going to return a short bias. Now we do need a default value, and basically the point is if it's not a long bias, not a short bias, then it's a no bias, and we just return the flat. If you look down here, that's actually going to prevent it from running the long signal or the short signal in either case. Okay, the oscillator is almost the same thing. So let's just out of the interest of speed, I'm just going to copy it And let's just define it like this. Now, same idea. We have some sort of condition, right? This condition is an oscillator. Okay, and I'm thinking ahead now. So basically, I'm gonna make this oscillator defined as a series, a data series. And because if you recall, I want to be able to, I want the ability to change this oscillator up very easily. And so what I'm gonna do is I'm gonna actually just define it as an I series. And then I can sort of plug in kind of whatever I want, right? So this is gonna be a property as well. And the proper convention, from an I series standpoint, and we're just be testing the current bar, if you will, and we're going to be just seeing if it's actually above, or in this case lower, than some sort of oscillation threshold, right? And that will be kind of a long condition. Okay, so think of the oscillator like, you know, the idea being we're in sort of oversold territory, and stochastic is sort of leading it and it's crossing above, but the oscillator is still below it. So anyways, I'm going to put that condition in there. Okay, so this zero, unlike the zero up here, right, this zero actually is going to refer to the 0th bars ago. Okay, oops, press the wrong key there. Okay, and we want to know if we're greater than the upper thresholds. Okay, those of you that are a little bit daunted by perhaps maybe coding in general, do stick around. We do have kind of a an alternative sort of non-coding method that Zach is actually going to demonstrate later. So, but I'm just going to forge ahead here. Still, we wrote a lot of kind of stuff here, but we haven't defined some of these things. So let's go ahead and do that right now. First things first, I got to define this lower threshold and upper threshold. We've already defined stochastic, if you recall. Okay, so these are going to be public properties that we can actually set the values to, and they're going to be doubles. All right, and let's just do that real quick. And it's just a shorthand for the get sets for the properties. And I'm just going to copy that 4 times because it's just faster than typing it all out. Okay. And I believe I named this one, was it oscillator lower threshold? Okay. All right, let's copy that. We can change this word real quick. Okay, we need to define the oscillator itself, and this one I'm going to put a little variable behind it because we do want the ability eventually to change it. All right, and we're going to expose that internally by simply returning it. Okay, so that's oscillator. Oops, it's actually an I series. Double. Okay, and its get method is just simply going to be returning that sucker. All right. Okay, let's compile it, see what we got here. Okay, and see if that compiles first. Okay, I almost never get an actual successful compile up the first one. It's very rare. Yeah, and we're running in a VMware inside here, so it's actually a little slow. Okay, so it worked out, but all right, let's add this to the chart. And like I said, it's time to do some testing. I apologize, my mouse is a little frozen here. Okay, let's do some testing here. Bring it up, and all right, there we go. All right, let's set these guys. The lower threshold for the stochastic is a 20, 80, and let's just throw in some numbers here for now. All right, I'm gonna take a quick poll. Can I see what we got here? anybody here think that this is, what do you think is going to happen when I run this? I don't think I see the I see the chat, but I don't see a Q&A. Is that all right? All right. Questions for a second. Okay. I'm having trouble just sort of expanding this little window here. There you go. Nothing should happen. And error, yeah. I guarantee you, you know what, you go in with the attitude that it's not going to work, you'll never be disappointed. And honestly, it's a little bit it's a little bit of a thing. You kind of have to almost expect the first time. It's never going to do what you want it to do. I have a suspicion that I can't pronounce your name. I'm sorry. It says it with a Z, but you probably caught an issue already, which is great. Okay, so you're right. Nothing happens. Why not? Okay, so this is where the problem solving comes in. Okay, first things first. I pretty much always have the NinjaTrader output window open because a lot of useful information comes from there, and the log is also your friend. The last kind of resource that I'm just gonna show you, which is very, very useful, is the trace file. Okay, so the trace files are just named by date. 2020, it is April 28th, and basically, it's basically 257 over here. You can see that file has just been recently updated, and you can see that the entire exception is the actual proper term when you're coding. The exception shows up here, and it's a null reference exception, which, believe it or not, is not set to an instance, which is the same thing as null reference. Don't panic when you see that kind of stuff. That's actually one of the easiest things to fix. All right, now, question is, where is it? Okay, so this is kind of where a little bit of ingenuity and sort of just getting some, elbow grease involved is sort of called for. And so, easiest way to do, I once had this boss, this is years ago when I was kind of in my early 20s, and every time I was stuck, he'd be like, I can't figure out what's wrong. His suggestion was usually the same kind of thing. He'd be just like, well, look, just start commenting stuff out until it works, until the exception's gone. Okay, so that's one way to do it. Okay, right? One way to go about it is I can just start, okay, well, let's take out all this stuff here, like that. Skip all this stuff, and just to test this line. Does this line work? All right, let's go ahead and do that. Let's just see if it does. And she's building. And she's good. Okay, hit F5 over here. You know what, I'm gonna clear this. So we start from scratch here. F5, okay, no error on the output. That would imply basically the error is not in that first line, okay? Another kind of common way to do this, however, is actually just to print statements. This is really old school stuff. I mean, this kind of harkens back to my days, and I'm talking like we used to have teletypes, and the internet was. Does anybody remember Lynx or Mosaic? That was kind of when I started. We had to code. We didn't have sort of elaborate developers environments like this, and we had to code. Yeah, hell yeah. All right, we got New York, USA saying hell yeah. So yeah, back in the early days, there was no sort of development environments. They call them IDEs now, integrated development environments, and everything was sort of, the coders had to do print statements to figure out kind of where problems lie. So a very common technique I find is just to scatter a couple of these suckers around. You make sure you clean them up afterwards. You don't want just these kind of lying around, but you can put them around like this, and then you can, through deduction, you can tell how far it gets before there's a problem. Okay, so I'm just going to build that again. There she goes. Hit F5, and let's bring up that output. Okay, so 1 fired off, then the error. That basically implies it never got to 2. Okay, so that implies that the problem is at this line. That also kind of implies, because oscillator bias, this call cannot possibly be a null reference exception in itself. The problem must be inside this method. All right, now first problem I noticed right away. Okay, so first line name number 87, this thing is just a double. Okay, that's just a value. There's no way that can be null. However, the oscillator, this thing is a property. That thing absolutely can be null. And if you look up here, you just look at your code really quick here, the oscillator, I never actually assigned it to anything. That is exactly what, oh wow, just somebody in the chat has said they used to code Turbo Pascal. That is actually, that brings back some really good memories. I learned Pascal when I was in junior high. It was a great language to actually start off with because it's very structured. It sort of forced you to stick with very, very, very strict conventions. And I think that kind of really helps in the end. Okay, so anyways, if you're probably guessing, I did that on purpose because I wanted to illustrate Fortran. That's awesome. Redneck has done Fortran. That's something that actually I never learned. I sort of avoided that one because Fortran kind of scared me. It was like writing English sentences. Okay, so basically, I never set the oscillator, and there's many kind of ways to do this, right? I can sort of put it into the defaults here. I can sort of set the oscillator here, for example. If I want to do that, right? I'm going to use the PPO for this example, by the way, guys. As you can see, I've got the PPO on my chart over here. I just realized I could point. You can actually see me, so that actually made a difference. Okay, and I can set it right here. However, what I'm just going to show you again. There's no right or wrong way to do this, but I like to keep things kind of, again, segregated. Okay, so if I put the oscillator code in the oscillator. You can put it in the set defaults if you want. You're not going to have an issue. I just like putting it here. This is also a technique called, in software development, it's called lazy loading. Okay, so the idea is you're not actually going to instantiate or you're not going to create your object until you actually need it. And this has some advantages. The number one being is you don't ever get objects that are created when you don't actually need them, only when they're needed on demand. And it works perfectly in an NinjaTrader environment because a lot these indicators can be created on demand. Some of you guys may know the main software product that we've created. It's called Bloodhound. It actually relies a lot on this principle, the idea of basically creating indicators only when they're needed, and that's why you're able to actually sort of add indicators on the fly and actually have them appear and kind of work right away. And so what this is going to do is at the very instance that the oscillator is needed, however, wherever that may be, in this case, it's going to be the first on-bar update call, we're going to actually test to see if the oscillator has been assigned yet. If it hasn't, create it and then return it. All right, so let's run this and see if we actually get anything working. Okay. All right, I've actually left the print statements in there just for, I tend to sort of, if I'm sort of debugging right now, I will leave them in here. Now, this is, in fact, I didn't plan on doing this, but I think I will, right? So sometimes I like to actually just do this. I like to create kind of a internal debug output method that will take some kind of the actual word I'm looking for is delegate. It's going to delegate the task to the print object in this case. Now this has several advantages. Okay, so what I'm going to do here is I'm going to go and scatter these about, right? Okay, and this is sort of thinking very long term. Okay, why did I do this? Okay, you might be asking, this does exactly the same thing. You're absolutely right, it sure does. The reason why I do this is because a couple reasons. Number one, say I'm done debugging. All I gotta do is just blanket that out. We're good to go. You might be worried about maybe the call actually costing some sort of resources. Believe me, the compilers these days are so sophisticated that it knows that if it's a call that has actually like an empty code or nothing to do, it's not even going to be in there. It's just, it doesn't take any extra time. The advantage of this, however, is that not only can you switch it off like that, but say you need to go back and debug another problem, you can switch everything back on like this, right? And if you're really fancy, you could probably even make some sort of like, you know, external switch up here, right? Like this, debug mode, right? And you can actually let the user set it at runtime. And then you can just do a quick check, like so. If debug mode, then actually probably even better, if not debug mode, return. That just gets you right out, and then you can have whatever we want after that. And so, and you might even be more sophisticated, you know, in the future. You decide you need more sophisticated outputs for your debugs. You can, you know, for example, log it to a file or something like that. You can just simply change this little method, and it kind of works everywhere, right? So, kind of a nice way to just keep your code ready to debug anytime. Right, so I'm just going to leave that in there, and let's build it again. So debug mode will be off in this case. Okay, so I obviously mistyped this real quick here. Right. All right, we're good to go. Let's run it. Okay, we do see some things here. Okay, so another thing right away, it's a little hard to determine if these are correct without kind of doing some really close analysis, but let's just do it anyway. Short signals from here. Okay, so this is definitely, this stochastic looks proper. I mean, this is the bar that it's crossing down from the top threshold. And let's just see if the PPO was actually above 0.1 in those circumstances. And it looks like that it was. Okay, but just to make it even more clear, just so that we can see what's really going on. And this is, again, a really nice thing, because you see how fast I just found it. I'm just going to go in and actually just paint the background. I'm going to paint the background a certain color when it's long and a certain color when it's short. And that's just going to help sort of dress up the output a little bit, so it's a little easier to visualize, right? Okay, so here we go. And we should have a little more colors when this happens, and then we can actually be more certain that the oscillator is also correct as well. Because I mean, let's face it, it looks like at least from the parameters I set, the 0.1s, you know, it happens quite often, so we don't know if it really was actually working or not. And yeah, okay, now we can see this little zone here where there's no paint. We can see that it was indeed below 0.1, which is exactly what we want. And so this is kind of dead zone in the middle, and that's exactly where this part where there's no paint. So it looks, on the whole, it looks pretty good. All right. Okay, so I'm going to step it up a notch, and this is again to illustrate the power of what I call like chunking it up, structuring your code properly. Let's make it so the user can select the oscillator at runtime, and we're going to use. You're probably looking ahead here. I've got the McClellan oscillator on the chart already, so we're going to use the McClellan oscillator as another possible choice. And to do that, I actually need to define an enum for the user. And this is going to bring me into kind of another kind of a really important topic. All right, you probably noticed that I put underscores on all the fields, right? So, sorry, all the fields, there's only one. The oscillator, I have a little underscore there. You may be wondering, why did he do that? Okay, you also notice here that I put an E in front of the definition of this enum. Now, there is no right or wrong conventions, but the point is you kind of need a convention. You need a convention that you remember, and that you know, when you're working with a team, it's even more important that the team all follows the same naming conventions. If you don't have the same naming conventions, it's just going to get really confusing really fast. However, even though even if you may be just a single developer, it's still very important. It's just as important as the chef, again, putting everything in place properly, structuring it, because believe me, in a couple months later, you go back to your code, you're not going to recognize it at all. You're going to be, you're going to be looking at, oh, I don't even know if this variable is a field or if this property is, what is it? And it's just going to make things a lot harder. Okay, so properties, I've basically always capitalized them, and they use something called Camel Case, which is very similar to the method names, which is basically each as you can see, this is a very common convention, camel casing. In fact, NinjaTrader uses camel casing everywhere, and that's the idea of every word is a capital letter. I use the same convention for properties. NinjaTrader doesn't use it for their enums. That's fine. Like I said, everybody's got their own thing. I like to use E in front of my enum definitions, so I know that's an enum definition. And every field has an underscore under it, and that way I know when I see an underscore, I know that that's a field. Okay. All right. So we are going to choose between the McClellan and the PPO, and we're going to go here and do it actually during the initialization. Okay. So I'm going to go in, and actually let's keep that line there. Okay. If we are if the we need some kind of property. If the oscillator choice, in fact, I'm just going to put what should I name it? Yeah, I'll just name it oscillator choice. And this will be a field. This field will actually be of type E oscillator choice is equal to the McClellan. Sorry, let me just showcase. Let me just actually, again, this is another way to skin the cat. But what I'm going to do is I'm going to actually switch this over to switch statement. The reason why is because it's one of those things, right? Think future, right? If you're, tomorrow you decide I want 3 different oscillators to choose from, a switch statement already there is just going to make it that much easier to add another one. And so now we're just going to check to see if this is a McClellan. Right, and just I always this is another newbie mistake that happens all the time. This is one of those things that gets ingrained with you when you take coding lessons or when you take it in university and whatnot. Is you always remember to put break habitually. You always put the break after the case. If you don't, what ends up happening? So if I took this out, right, it's actually going to fall right through, and what's going to end up happening is whatever you set it up here is just simply going to get ignored, and that's not what you want. Right, so I'm using the McClellan oscillator, and what do we have for the problems? 13, 19, and 39. Okay, and back to the PPO at 12, 26, 9. Okay, I didn't forget that. Put that break back in there. Okay, so if that break wasn't there, what's going to happen if the user selects McClellan? It's going to assign the oscillator to McClellan, fall right through to the next one, and assign the oscillator to PPO. So that's not going to help at all. Of course, we don't want this line here either. That's also just going to simply assign it to the PPO, and that's really not going to help either. Okay. All right. Quick look. That looks pretty good to me. Of course, everything does look good. Oh, right. I did not actually create this, did I? Okay. We need to actually define our public property. It's a type oscillator choice, and we're just going to get and set it. Okay, like so. All right, let's compile this sucker. Let's see what happens next. Okay, perfect. Let's just check at the settings. Okay. Debug mode, we'll leave that off. We're on McClellan. McClellan's got it's a slightly more wild oscillator. Goes from like these little lines here are already set to positive 100, negative 100. So I'm just going to go ahead and do that. 100, negative 100, 100. Okay, and let's let her rip. And boom, did not work. Okay, this is where the detective in you have to come out again. Okay, first thing we're going to notice is this mysterious message here probably doesn't make a whole lot of sense when you're first reading it, okay, unless you've seen it a dozen times already. So if you haven't seen something that shows up, honestly, the easiest thing to do, and don't be ashamed of doing this, I'm never ashamed to admit this, is to just simply Google it. There is a absolute, treasure trove of information out there. You got the world's best search engine, and it's, and most likely whatever error or problem that you've encountered is most likely been encountered by someone before. And it's been encountered enough that someone has decided to write about it, post it on the internet in the NinjaTrader form. In this case, Google will most likely pick it up, and you'll find at least an explanation to what is going on here. So I'm just going to fire up Chrome in a second. And there she is. You must think I'm running on a 486 or something, right? Truth is, again, I'm working in a VMware, so things are really slow. Okay. Now, I'm going to Google this right away, just verbatim, and then see what we get. We got some stuff about the McClellan indicator in general. This honestly doesn't look like, just immediately is going to look like it's very useful. Now, so another kind of little tidbit technique or tip, if you will, is you want to sort of generalize your error. Okay, so this is an error that's specifically talking about the McClellan oscillator. Let's just take a look at what the error, like the actual error text would have been, kind of without the McClellan oscillator in there. I'd like to also just tell Google, hey, I'm looking for something that's very specific to NinjaTrader. I'll just throw the word NinjaTrader out there in the beginning. Google will sort of pick it up, and because it sort of puts it all together. Also, this is a very specific, this is a time series in this case, or sorry, another data series. I'm going to take that out just again to take out sort of any specifics in this error message. Take a look at it again and see what comes up. All right. Okay, so basically we got a host indicator. Okay, that's basically a hosted indicator. That is what our demo indicator is. It's actually hosting the McClellan indicator, and it's trying to load it's trying to load the McClellan indicator, which in turn is trying to load something. So if we read this, and I'm just going to spare you the details, okay, but basically you open this up, you look into it, and you look closely enough, there's kind of a new thing in NinjaTrader 7, this is 8, sorry, that is not really there, wasn't there in NinjaTrader 7, and that's basically any kind of indicator that actually loads additional data series the host indicator, meaning the main indicator that you're sitting in, also has to load that first. Okay, so that's essentially what this is saying. Okay, so how are we going to find out what it's loading? Well, in this case, we are lucky because we actually have the source code right here. Okay, McClellan oscillator. Okay, I can just literally double click it. See right in the configure, it's loading up these data series. Okay, however, what if you don't, what if you don't actually have that? So I'm not sure if I probably have enough time for this, but the general gist of it is if you don't have kind of access to the source code to find out what the data series are, well, you can actually go through and iterate through it. You can peek into the bars array object of that that indicator, and you can actually print out those what those two are. I mean, probably go for it right now, I guess, but well, you know what? Let's just forge on to see if we can get this working. Okay. All right. So this just the way NinjaTrader 8 works. Again, if you just kind of do this enough, you'll start knowing these things in terms of the quirks. But the way NinjaTrader 8 works is you must load these data series inside of the configure state. So I don't really have the luxury of sort of popping it in here anymore. And so this is one of those things that, again, I'll probably do kind of like another method. Initialize, let's call it indicators. Okay, so all the sub indicators inside of it. And that, again, makes it a nice little spot where I can, let's just type that out. Okay. And we only want to load things if we need to. Okay, so in this case, this is the only case where we need to do it is when the user has chosen it. And especially, we got to think what's going to happen, right? When you run this thing, and especially when you don't need it, don't load it. So only when the oscillator choice is actually McClellan are we going to actually go ahead and load those two data series up. Okay, like so. Anything else, don't do it. You're just going to bog down your indicator unnecessarily. You always want to avoid that whenever possible. Okay, let's build that. All right, so this is taking a little bit of time here. Okay, and my mouse is frozen for a second here. Yeah, all right. VMware, all right. Okay, let's run that, and boom, it looks okay to me. Okay. Now, I'll just kind of point out before I sort of conclude here. Sometimes you kind of get some weird behavior, and I was sort of testing things out a little bit. And I see this all the time too, is sometimes your chart will be getting this weird state. Your code is perfectly sound. Everything actually is written properly, but it still will not work. You get these errors that literally just don't make any sense whatsoever. Don't be afraid to take it off your chart. Just remove it, put it back on. Okay, sometimes it just works. Computers can be pretty mysterious sometimes. I mean, there's probably some very, there's some very technical explanation for it, but regardless, that's always something to try. It's almost like rebooting your computer. Okay, let's. I did mention that at this point, that we are going to show you two different methods on how to build this. So I think it's now time for me to pass the buck over to Zach, who's going to show you kind of a way to do this. The idea is if coding is kind of not really your thing, it's not for everybody. Like this, I'm kind of a weirdo because I'm passionate about this stuff. I like this stuff more than trading. That's actually why. That's actually the main reason why I build the tools that I do. So let me just go into a very quick story. the story behind Bloodhound itself was actually a tool. I wanted a tool for myself that I can just quickly create trade systems and do it in real time without having to code it. You know, because even though I like coding, I'd like speed and efficiency better. So originally that's what Bloodhound was for. And so we're actually going to show you real quick. I'm going to pass the buck over to Zach, and he's going to show you how to build this, how we can do it in an alternative method without having to learn how to code.
Hey guys, let me get my screen switched over here. Just a moment. There we go. All right, you guys should see my screen in just a moment. And yeah, I just want to make. I've been trying to answer some of the questions coming in, into the questions window there. And I must say, I'm kind of surprised at how many experienced programmers are actually in this webinar. So, I don't think you guys really I don't think you guys really picked anything up. Yeah, at least for the experienced programmer, I don't think you guys picked up anything new from Jeremy. But what I'm going to show you here, as Jeremy said, this tool that he created originally, for himself and myself, was to, greatly speed up, the testing phase. Instead of having to write code every single time, compile it, test it, and you guys know the drill. Go through that whole iteration process. So he kind of created this modular piece of software here, so you could just very quickly prototype stuff, and see, is this idea, going to take us on the right track? Is this something worth further, investigation? That's basically how Bloodhound was created, was just to help us speed through, prototyping ideas. So, and then lo and behold, before we knew it, it actually turned into a business. So, so what I'm going to do is just quickly for you experienced guys, I think this part of the webinar is probably what's going to be most helpful for you guys, to be able to see that there's a much faster way to be able to prototype and develop systems, and then if you want to, then you could go and hard code it if you wanted to. So so basically I've got the same chart up here as what Jeremy had, right? I've got the stochastics, I've got the McClellan, and I've got the PPO indicator here, and I'm going to basically develop the same crossover and oscillator system that Jeremy had hard coded here. The first thing that Jeremy was doing is, he was looking at the stochastics and identifying when it was crossing down of the overbought area or crossing up, of the oversold area. And so to do that, rapidly, with Bloodhound, we have these crossover solvers that'll look for crossover conditions. And so for this one, let's see here, let me just give this a name here. All right, so I'm going to look for crossing up over the 20 value. And so from here, you can see I got a list of Ninja's indicators, and I can select the stochastics indicator, and you can adjust any of the properties if you need, even adjust some of the plots. So if you didn't want to use the D, if you want to use the faster K, you can just go down there and select the K plot instead. You can even mix and match plots. Some indicators, it's kind of helpful where you might want to use one plot for looking for a long signal and use the other plot for a short signal, but not for the stochastics here. So let's go and select that. And let's connect this up before I get going too far. So there's the indicator, stochastics plugged in. And the next thing is we're looking for a crossover of the 20 fixed value, of 20 there. And there you can see on the chart, right, all the little crossovers there, whenever that stochastics crosses that 20. And in this case, I'm only looking for the long crossover conditions, right? So there we go. So we just isolated this to only showing us when stochastics is crossing up like that. So that's one of the crossovers that we're looking for, right? That's this crossover of the lower area. So now we need to find the cross down of the oversold area. So what I'm going to do is I'm going to take a little shortcut and make a copy of that solver I just made. And I like to rename things here, like so. And let's adjust that fixed value. And instead of looking for the long, situations, I'm now looking for the short condition for this, the cross down. So there's, what we call a solver, a new solver made. And then I can just go to my existing nodes, and there's that new solver that I had just made. Put that in here, connect that up, and there we go. So now I can see, right, all the times the stochastic crosses down the oversold, or I'm sorry, overbought area. So, and then next, if you were writing this in code, you would use an if. Actually, no, I'm sorry. If you were doing this in code, the way Jeremy showed it would be different, but we're going to put both of these conditions into an OR node, and that effectively joins the two conditions together, right? So we can see the stochastics crossing, in and out of the overbought and oversold areas like that. So, and now the next step is to add in our oscillator there. So let me add in, the PPO oscillator there. And this time we're going to use the threshold solver, right? Because we're wanting to know if that oscillator, the PPO, is overbought or oversold, but we're not looking for crossover conditions. We're just looking for overbought, oversold areas here. So let me connect that up. And let me give this a name here. And let's see here. I'm guessing, let's see, this is the ES. So let's do something like point 1. Yeah, I'll use 0.1, but first let me plug in the PPO indicator here. And there's the PPO. And again, you can adjust the periods if you're, using something faster or whatnot. But all right, so next, let me put in the threshold levels that I'm looking for. And there we go. And then plug in the outputs like so, right? So you guys have probably, most of you guys have figured out that, this little system that we're putting together is like a counter trend type of system, right? So whenever it finds indicators in the overbought situation, right, overbought area, that it's producing a counter trend short signal. So here we go. Whenever the PPO, right, is above 0.1, getting a short output, as a short filter. And if the PPO is below negative 0.1, we're getting a long output, like so. And so next, I can join, right, basically I could take the stochastic crossover conditions and combine it with basically this oscillator filter, right, kind of a filtering mechanism. And now we have, filtered stochastics crossover signals here, right? And so let's see, to mimic, Jeremy's little enum that he built, where you could select between the McClellan or the PPO, then again, what I can do And I can go over here and, well, actually this time it wouldn't be a shortcut. So I'll just do this from scratch here. Let's just grab another threshold solver like so. Let's connect it up. And let's see. And so this will be the McClellan. And I'm going to look for the 100 threshold level. So, and actually, let's see. Let me go back to the PPO and put in the 0.1 for my threshold levels. So I also like to kind of keep a strict naming convention here for my solvers. All right, so back to the McClellan. And let's see here. Next, let's plug in the McClellan indicator. So again, I'm just going to scroll down. And I am sorry about I'm going real fast here, guys, but I think we're kind of running out of time here. So I'm just trying to speed through this quickly as I can. And again, I'm going to put in my, threshold levels that I'm looking for this oscillator, to be at, to be above or to be below, I should say. Like so. And again, we're looking for overbought, oversold situations. And so, all right, so the next thing is, you notice down here, Bloodhound has basically detected that, one of the indicators, is using a secondary data series or time frame or instrument, so to speak. So it just basically wants a reload. So that way Bloodhound can load up that extra data series that the McClellan indicator wants. And so with that, let's go back here. All right, so here's our little McClellan, threshold levels here, looking for the, let's shrink this up, right? Look, identifying when the McClellan is in the overbought area, looking for a possible, return to the mean, or counter trend situation, or if the McClellan is in the oversold area, right? And so we're getting a long or a green output. And so if you wanted to be able to, switch between the PPO and the McClellan, I can just simply disconnect one, connect the other up, and take a look. So I can easily, rapidly prototype and, look on my chart and see those signals. So you guys can see, the green and red buy and sell signals there, and, quickly be able to, evaluate, this idea, which actually, we just did a quick Google search for some very simplistic, trading ideas. This is what we found on Google, the stochastics double crossover. And then we thought, well, to make this coding demo a little more interesting, let's throw some oscillators in here. So Jeremy could give you guys a little more of an educational demonstration there, of some good programming techniques. Yeah, so there we have it, in Bloodhound, in just a couple of matter of minutes. And, once you kind of, for you experienced guys out there, once you kind of come up with an idea you like, of course you could just use Bloodhound, or you could hard code this now. Once you find an idea, you can then take the time and hard code stuff and, elaborate on it and, tweak it and, what's the word I'm looking for? I guess highly customize it. So, all right. Well, anyways, that was my quick little short demo part. And so with that, let me turn it back over to Jeremy.
All right, thanks, Zach. I'm just going to sum up what we saw today. Just again, some key takeaways that I hope you guys would have learned from this little session. And number one is it definitely pays to sort of approach development like it's an iterative process, not something that you're just and then in the late 90s. Some of you guys are around programming since then, because I'm just kind of curious. There used to be this thing called the Waterfall Technique. It's like, it was, I think, probably named in mockery, but the whole point was like you'd have all these teams developing a huge structure, like document of, sorry, you'd have like this business document that would say what your software had to do, and everybody would code up their team, code up their little part, and then at the end they would try to throw it all together to see if it worked, and they, you know, hope and pray. And it, honestly, it just didn't work. It never worked out well. It was, oh, somebody's been programming since the punch card era. That's incredible. Yeah, the waterfall software technique was very quickly replaced with what we call now these days an agile development methodology, which is the idea of like you're iterating constantly, and instead of building like just developing for a long time and then just slamming it all together and then hoping and praying and then going through a massive debug cycle. Agile development, to be clear, this isn't exactly what I showed you, but aspects of the agile development is to iterate a lot and actually try to create a piece of code that actually works in a small kind of like solves a small part of your problem first, and then review it, make sure it works, and then just keep adding to it. So at every kind of, you have these little checkpoints you try to make for yourself. So that you, again, that makes it a lot easier to solve problems. And actually, if I were to go back to the code, a common technique is actually called stubbing. I didn't intend on sort of getting into this, but I think I will just because I'm talking about it. But a very common technique is to actually write what's called stubs, right? So if you recall back here when I was creating this on-bar update, I sort of did actually. I sort of built these stubs up, but then I wrote the actual code inside of them. But imagine, right, like, you know, if you just sort of wrote it all like this, let it compile, and then just put little stubs in here, right? It wasn't actually the full logic. Your thing would still kind of work, right? Your software would still run. You'd still see things on the chart. Not exactly what you want, but you know, that's the whole point. Is you want to a very common technique is to actually build these little stubs out and just really quickly just implement something very trivial in them, just to make sure that the pieces are all fitting together properly. And that's all kind of lends itself to the idea of iterative development, or in the proper term in software parlance is called agile development. Okay, yeah, and that's really actually what I was talking about, is this testing before combining. That is the whole crux of what I'm trying to get at here. And then also, like, if you notice, I didn't hesitate to create new methods and chunk things out, put it into separate little methods, and believe me, for example, the code base for, say, Bloodhound, it's I don't really have a count for it, but it's probably nearing the millions of lines. I don't even know at this point, but there are many files, and if the whole thing was just in one single file, it'd be an absolute nightmare to work with and debug and sort of add new features with. So it's actually split into hundreds, like literally hundreds of files. Each in itself have, you know, there's different objects. And then I find most of my job is actually just trying to figure out kind of how to properly structure stuff. And then once I've figured that out, the development part of it is actually usually fairly simple. So, and here's a very simple example here. We put up a slide of a little bit of code from Fat Tails or Harry on Futures.io. It's a brilliant programmer. Actually, a lot of his stuff is free. The source code is actually up there. You know, he didn't, like, I didn't talk to him, or we didn't talk to each other in terms of plugging him, but yeah, his stuff is pretty amazing in terms of just following the right kind of structures and stuff like that. Or not right, sorry, there's no right or wrong, as I was trying to say, but following a really good sound structure. You know, and doing it like this allows you to sort of reuse pieces of code all over the place without having to rewrite it, right? So for example, this is a piece of code that he wrote, and the price marker being formatted or whatever in this case may be called upon many times and referenced many times throughout the code, and so that's why it's sort of broken out into its own separate method. And so it's very helpful thing to do, again, is to structure it and figure out, kind of think before you actually develop, like how you're going to structure it. And don't be afraid as well when you're going through it and you're just like, you know, you're writing the lines, you're just like, oh my gosh, you know what, I think this piece here should really be in its own method. Just stop what you're doing, copy it all, cut it out, put it into a separate method, and keep continuing. That's, you know, that happens all the time. I'm always refactoring things. It's called the term is called refactoring. I do spend a lot of time refactoring in terms of like moving code around to different methods just to make it more organized. So there's a fair bit of work just doing that. And you won't believe how much time that actually saves in the long run. And again, you saw me there using, like, just getting crafty with the resources in terms of looking up how to solve a problem. And Google is really your friend here. Like, don't be afraid to use it. I think I have this kind of lends itself well to somebody asked in the questions here. If Jeremy, could you please show us a link to a good NT programming manual? Well, there really isn't one out there other than the stuff that's already on NinjaTrader. NinjaTrader has, of course, their reference guide as well as kind of a coding guide and whatnot. But honestly, it's not one of those things like like and this is the way I kind of learned it is basically problems and issues came up, I Googled them. And a lot of them just go straight back to NinjaTrader's site. Some of them go to Features.io, and that's your manual. You have kind of like at your fingertips an imaginably huge manual that you can index and you can find exactly what you're looking for at any given time. And so I guess the best answer, and this is probably not the answer you're expecting, but the best answer is your manual. Really, the best manual is Google, which will, generally lead you back to the NinjaTrader website and Features.io in a lot of cases. So yeah, that's basically what we got here for today. But I'm really happy to stay on and answer questions until I guess we get kicked off here. But in the meantime, I'm quite surprised actually. Like, there's a lot of really seasoned and developers that are people that have been working with computers for a long time, even longer than I have. SigmaTrader, I remember that must be Bob, right? Bob Rose. Yeah, he said he worked with the ASR 33 teletypes. I haven't even done that. I was born in '76, so it's long before the internet. It's really hard to imagine a world without the internet these days. But I was a developer long before the internet existed, and certainly the ASR 33 teletype. I don't even know if I'm sure that's a really old computer that it's probably what I'm guessing 70s or 80s, late 70s, 80s. Okay, yeah, let me go through some of these questions here. In terms of the replay, I am pretty sure, Terry, I probably can answer that, but I'm quite certain that basically all these webinars are recorded. So don't worry about that. They'll all be posted up on Features.io at some point. Yeah, I'm just laughing at New York, USA's comment about using macro assembler, Cobalt, and Fortran. Those are actually all languages that predate myself even. So you never learn C. C, I think, really took off in the 80s and eventually got superseded, if you will, by C++. Somebody actually kind of asked a little about C++. I don't know why. C++ is actually, it's one of those things. Okay, there's a lot of hardcore developers out there that learned in C++. I learned my trade in C++ first, but having discovered C#, I'll tell you, I'll never go back. C++ has some advantages in terms of in the hierarchy of development languages. It's considered what they call a lower level language. Lower level doesn't mean that it's less sophisticated. What it actually means, it's just lower in the hierarchy in terms of it's closer to the hardware. And so C++ allows you to actually access a lot of hardware. It's closer to what the computer is. This is a really bad way to describe it, but it's close to what the computer's thinking. I think the computers don't think, but computers have memory that needs to be allocated. You have to work with stacks and pointers, and those are all kind of just the way the computers manage memory and manage processes. Those are all things that are kind of lower to the hardware, closer to the hardware, and C++ gives you kind of access to that kind of stuff. The reason why I don't like it is because, you know, those, at least for the, you know, a lot of the jobs that you're trying to accomplish, you know, those are more or less irrelevant to what you're, you know, at least what I'm doing, and unless you're, you know, into sort of hardware development, or, you know, writing, I was gonna say writing drivers. I think drivers are generally written in C++, but I could be wrong. Some of them are probably written right in machine code or like ASCII or assembly, I should say. I'm just rambling, but basically I use the tool that's going to get the job done the fastest and the most convenient way. And C#, it fits that bill on so many levels because there's so many things it handles that you don't have to worry about, like memory management, pointers, you know, the memory allocation stuff. I remember back when I was learning this stuff in university, was just an absolute nightmare. It was just, if you didn't properly handle it, like you just, very easy to just get memory leaks, and your program would just spiral out of control. You know, so in fact, I think for the most part, most software out there, most commercial applications, business applications, I should say, games are a different kind of animal, but where it pays to be really low level because you need to be optimized. But for the most part, most business applications use higher level languages like C#. And if you think about the whole web developing industry, that's even a higher level in terms of it's a scripting language that's actually using another application to run it. There's no compiling. It's just running it's just running inside of another kind of application. But yeah, so C# is actually, I'd say, a really good choice. If you want to start learning coding, C# is a great place to start. It's very relevant, especially for NinjaTrader. Well, I mean, it is relevant for NinjaTrader because that's the only thing that it supports. So, all right, let's go through here and see what we got here.
Hey, I think we got enough for like one more question, but we are getting long on time, so.
Yeah, I did a lot of babbling there. I don't see anything in here that's sort of any pressing questions. So I'm just going to wrap up and say thanks, guys, for there's some pretty funny comments though about just kind of showing my age in terms of development. There is one question I think for Zach here. Okay, yeah. So just let me just advance the slide. I'm sorry, guys. If you are kind of interested in what Zach was talking about Bloodhound, that's our website there. But yeah, I hope you guys enjoyed this coding demo and learned something from it. Believe me, it's software development is kind of a lifelong trade. It's not something that there's no end to what you can learn. So there's always something new and exciting, and it's very humbling sometimes, to be honest. But yeah, I thank you guys for showing up, and I hope you guys have a great rest of the week.
Absolutely. Thank you for the webinar, the information, and for spending some time with us this evening.